Welcome to the Structural Engineering Podcast.
We're your hosts, Zach and Max, structural engineers passionate about unraveling the complexities of our architectural wonders.
Whether you're a seasoned professional, an aspiring engineer, or simply fascinated by the science behind skyscrapers and bridges, you've come to the right place.
In each episode, we bring you insightful interviews with leading professionals.
So grab your hard hat,
or maybe your calculator,
sharpen your pencils, and get ready to explore the fascinating world of structural engineering. This is
the Structural Engineering Podcast.
We are back and have one more chapter in our discovery of ultra-high performance concrete. Now, in the last episode, we took a step in the engineering side of this very cool material. With UHPC, we had the opportunity to get the full breadth of the story: design, fabrication, and direction. For this episode, we are talking with Joe Bunkers, the president of Gage Brothers, the precast team that takes the messy EOR guesses and translates these into the ideal use of the material. Take a peek in the show notes for links to Gage Brothers, and direct to the very cool project that started this conversation. And with that, let's get started.
My name is Joe Bunkers, and I'm calling in from Sioux Falls, South Dakota. I'm the president of Gage Brothers Concrete Products, and we are a precast concrete manufacturer for all things precast concrete above ground. So we don't do any of the utility work, but we do all of the construction products, structural and architectural, and a little bit of infrastructure with bridge girders. I've been at Gage Brothers for 25 and a half years. Started here as a drafter. Worked my way up through quality control. So I drafted for just over a year, did quality control for our company it's about 15 years that I had that under my purview. Handled all of our on-site installation, kind of oversaw installation, oversaw any field repairs that had to be done. Then ultimately moved into sales operations and took over as president about 3.5 years ago.
Wow, that's really cool. So for any of our listeners that don't know what precast is, could you explain what is precast?
Yeah, precast is a slang term for prefabricated concrete products. We call it precast because it's cast prior to going to the job site. The comparison would be cast in place concrete, and that's concrete that would be poured on site. We pour it here at Gage Brothers in a factory. Then we put it on a flatbed truck, haul it to the job site, and use a crane to put the finished piece into place.
And where do you typically see precast being utilized in the built environment?
And so it can be used just about anywhere in the built environment. In our area, the one of the biggest uses is we'll use it as the facade. So in architectural precast cladding will cover the exterior of the building. And with the energy codes that keep bumping up, we do an insulated wall panel. So we have a concrete face, insulation, concrete back. So you can have an architectural facade that's insulated, that's also really fast to put up with a hardened interior surface. That is the biggest sort of movement in the market, would be the increase of insulated wall panels. But we also do buildings where we do the whole structure. So we're doing the beams, the columns, the floor system. And we do a decent amount of those up here too. And one of the other really big uses of it is all of our apartments in this region, not all of them, a lot of them have underground parking. So when you park a car under an apartment, you have to have a fire cap. Precast makes a really good fire cap to protect the apartment from the parking underneath it. So we use some beams and columns and then what's called a hollow core plank as a flooring system to create that fire separation also.
So from an engineer of record standpoint, where's their scope versus your guys' scope, and how does that integrate together?
Yeah, so we work in conjunction with the architect and engineer to design the precast system. Typically, the structural engineer of record owns the overall design of the building. So they will usually attempt to size some elements. They will draw in kind of what their overall intent is. They're responsible for all the load path, make sure that everything rectifies out and works. What we're responsible for is taking their rough design and turning it into a very specific set of precast drawings where we draw every single piece of precast or every element into now we're doing everything in a Revit model. So we'll draw it into the Revit model, integrate it with the architectural, And then we're responsible for designing all of the precast elements themselves. So we aren't responsible for the overall structural design of the building, but every precast element we'll have an engineer design and stamp that, and then we draw it and make it.
Okay. How close do us engineers get to, on a correct size for what you guys are doing? How often are you coming back going, that wall's got to be a little bit thicker, that double T's got to be a little bit deeper, or hollow core? Or are we as an industry pretty good at taking our first guess?
If I'm just being honest about it, used to be better.
Okay. Yeah.
But I think that's the case for so much of not just the engineers. It's the engineers, it's the architects, it's the contractors, it's in some cases a precaster. While technology is awesome and helps us be so much more specific and advanced, I think there was an art to doing it by hand. Back when an engineer or our engineer or drafter would draw this by hand, things were more thought out because you didn't want to go change it.
Right.
So we would rely on the engineer's information more. They would spend more time, oftentimes, with the precaster up front designing this, preliminarily designing the building. So there were fewer changes. Now, with the advent of technology and copying everything, we just get it close, drop it in there, and let the precaster figure it out. And we see that. And we also see it if you just look at our own engineering and drafting, we lost that art of really thinking it through prior to putting it into the computer because it's so easy to manipulate and change now. So I think just globally, everything up front has become less accurate, but through technology, it's ultimately more accurate in the end and better to see what you're building.
Yeah. So you guys would be looking for something to pull out there is to have the engineer integrate you to the design team early on, maybe even day one, to be part of that. Is that, I guess, the best process?
It is the best process, and it's the least commonly used. But quite honestly, let's just, oftentimes in my industry, people like to refer to, like, if you're buying a car, would you buy one with a scratch? No, but I can fix the precast. But if we do take it to that car analogy, when's the best time to design the car you want? Before they make it, right? As soon as the process, if you want different tires, it's easier to have them put different tires on it before they put the first set on. And I liken that to doing precast. The best time to get the most value out of a system is early on in the process, because once you put it out for just hard bid and the drawings are out, nobody wants to go backwards and change it. So you're sort of locked into however good or not good that design is once you put it out for bid, because nobody wants to spend the money to go backwards to change it because some precaster came up with a new, this could make it a little bit better. Well, that's all fine and great, but it's going to cost me time and money as an engineer. And quite honestly, I want to do the next job. So the sooner the better. And, we get pushback on that because then there's a perception that we're trying to force our product or, make it work just for us or, something like that. But it's really done collaboratively. It is the absolute best way to design a building.
Yeah, I couldn't agree more. I think that process would be the best for every building. Max and I've talked about it many times, like having all the subs that are going to actually physically build the building in the room day one as we're starting to design it and understand how, say even for the foundations, how they want to tie the rebar, how they want to put their forms up. If they can tell us how they want to build it and we can check and work with them, there's just no better process. Like they're going to be excited and happy to build it. We're going to be happy because they're on board with what we did. But it seems like that process just hasn't occurred yet. So
I've had that process or close to it on one job. We were fortunate to build the Colorado Supreme Court in downtown Denver there. So the Supreme Court building is a stone-clad precast building. And then there's a 12-story office building standing right behind it. We did those two jobs with Mortensen Construction. Oh, it's been over a decade ago, I think. But it was the most collaborative job I have ever worked on. So I flew out to Denver every other week. And then in the off week, we're on a video call like we are now. And we would walk through every element of that building with all of the partners around the table. So it was the architect for the office, the architect for the court. It was the structural engineer of record. It was the cast in place, the steel, the owner's rep, the windows, the precast, just everyone was there. So you would walk through and ask the questions of each other, make the modifications as you're going. And it was the most fun, the most collaborative, and I think the best built environment that we've been part of. It was just so well thought out. And a lot of people, Zach, talk about BIM and how that, can transform this building environment. And in my humble, sort of jaded opinion, it's just a really fancy tool that we don't use as well as we could. I hold that Colorado Supreme Court as sort of the, that's the mark we need to go hit every single time. But usually what it turns into is draw it in BIM, send it to us. We'll tell you if you have a clash, change it, send you RFIs, do that whole wasteful process again and again, but we're just going to have fancy tools to check it.
Yeah.
And I just think in general, we're missing the mark yet.
Yeah, I couldn't agree more. I think we found in the last 4 years, with COVID shutting down the whole world and everything, that we've gotten away from this like line of communication and a collaboration for sure. It's more of it's in the BIM model. I adjusted it, you figure it out, and it's this really bad process of not asking questions and working together. If we can sit at the table and the precaster could say, you know what, Zach and Max, we could do this so much better and quicker and frame this differently in these corner, and the architect could be there and go, I could adjust some things a little bit. We can, and it makes everyone's life easier, but it seems like we're more reactive to everything than really trying to think through things and being proactive. It's kind of a weird world we're currently in, but I really like to hear that your example there. And
and I think the other thing that happens is egos get in the way. And you have to just be able to get those people in the room and say, okay, when it comes to precast, the precaster probably knows the most in the room, and that's okay. And when it comes to structural engineering, the structural engineer probably knows the most in the room. When it comes to windows, I'm going to look to the window guy. But that means that architect, engineer, owner's rep, contractor, whoever has to be able to say, okay, I don't know the most about everything, and I'm willing to give up some semblance of control in order to have the best building and the best relationships through it.
Man, I couldn't agree more. Well, moving in for what we're here today, ultra high performance concrete, or UHPC. What is UHPC, and how did the Gage brothers get involved with this?
Yeah, so UHPC is a concrete product at heart, but it's just a very different product than traditional concrete that we're used to walking on, driving on, or seeing in our buildings. What I talk about it, not being an engineer, I talk about it in pretty simple terms. So when somebody asks me, what's the difference between UHPC and regular concrete, I start with the strength. In general, it's going to be roughly 4 times harder, resistant to crushing than the concrete that you walk or drive on. And that's always a good analogy, because oftentimes we're on a sidewalk or on a concrete floor in a building, and just the concrete itself is 4 or 5 times harder or resistant to crushing than that concrete we're standing on. But I think more importantly is its ability to resist cracking in a bending. That too is a 5 or 6 times more resistant to cracking. And we all love to laugh and joke about concrete. What is one thing we know about concrete? It's going to crack. Well, with UHPC, it takes a lot more tension for that to actually form that crack. And then when it does, it actually gains strength because of the fibers in it. So it hits that initial crack, but then it has to get 25% more resistant to cracking before it ultimately fails to be considered good concrete or good UHPC. So again, you love the engineers answer the engineering questions in layman's terms. That's how I think about it as a difference. If you were mixing the UHPC, what you're going to notice first is we never put coarse aggregate in it. It's all about fine aggregates. It's sand. In fact, it's a very small sand. And then it's cement particles. And if you've ever felt that cement particle, it's pretty fine dust to begin with. But then we also put in particles that are smaller than the cement particles, whether it's a silica fume, ground blast, the slag, stuff like that. What we're really forming is a very, very dense, compactable mix. The really smart engineers talk about particle packing, density theories, but really what we're saying is that, the cement particle might be yay big. Well, we need a smaller one to fit in all around that. The sand the cement, and then the small particles really comes together to form an extremely dense, impermeable concrete product. It behaves more like gelatinous isn't really quite the right word, but maybe more like a cake batter, where it doesn't really run or flow. It's pretty sticky.
Hmm.
Especially then with the fibers in it, it doesn't want to just run and flow down your forms. But we also then have to mix ice in with it to control the curing temperature, keep the temps down while it's mixing. But then you mix it, we mix it just very much like standard concrete. It goes in our same mixer. We do mix it for we're about 15 minutes of mixing time instead of the 3 to 5 minutes that we'll mix a traditional batch of concrete. So it does just take longer to get it to be homogeneous, to really get the fibers mixed in, to get all of the cement particles and other particles really mixed and combined with the water and the ad mixers to get it to ultimately perform the way we want it to perform.
So how did you guys get involved with UHPCs?
So Gage Brothers has a history of being, we aren't necessarily the creator of new intellectual property, but we've always been an early adopter. So it's sort of a natural thing for us to jump into the deep end pretty quickly. And we're a member of PCI, which is a Precast Concrete Institute. PCI undertook a study where they developed a non-proprietary UHPC mix. So that way a precaster like us can make our own mix, buy our own ingredients and mix it instead of buying a pre-bagged. We can get it in super sacks from some suppliers, but it's like 2 or 3 times more expensive than if we just mix it ourselves. So PCI doing that research gave us the foundation to be able to actually just say, okay, well, let's buy the materials and do it. We also teamed up with Colin and his company then to say, okay, how do we apply this in real life? It's been tested. It's, the results are there. We want to actually go apply it. So we're working with eConstruct, Colin and Dr. Tadros at eConstruct, just on, looking for an application to use it. And at that same time, then in the first year of the pandemic, when all of the supply chains were just messed up, right? So prices were insane and availability was unknown. We were looking at a job in Sioux Falls, the Steel District office in downtown Sioux Falls, and they were really having a hard time nailing down a price for the structural steel and when could we get it. So I worked with eConstruct and Dr. Tadros and Colin to design this building out of all precast using UHPC beams. And I floated the idea to them. I said, I think I can solve your problem of not knowing when you can get it and what the price is ultimately going to be. Here is an all precast building for you using ultra high performance concrete beams. Not only can I, give you the price then that you're looking for, I can also eliminate all columns in the middle of the building. So we were able to keep it at or about the same price as what they're looking for, but now there's no columns in this office building on the interior of it at all. So we gave them a better environment while holding a price and introducing a new product. But it was really that research through PCI, the vision that we shared with eConstruct, and then a willing owner to say, yeah, you know what, let's give it a shot. That got us started in it. So now we're all in. We're looking for the next great job to do with it. We're looking at some telecommunication shelters that we might be making with it. We're also designing what would I talked about that podium under the apartments. How do we design one of them? Again, if you can get all those columns out of the underground parking, it's huge for the user interface, that user experience, especially if we're talking about putting them under, we have a lot of elderly living apartment type places here in Sioux Falls, as we do all over the country. If you can get those columns out of it, just makes it easier and safer for the residents to use. So that's where we're looking to bring it next, is continuing that office type building and then also change that podium design.
Yeah, I think that makes a lot of sense. And I think if there's ever to be an architect that listened to our podcast, that hearing that there's no columns is probably the most exciting thing they could ever hear. So I could see a big push to go that route.
And the architect that we worked with, who ultimately had to do a complete redesign of this building with us after it was designed, Koch Hazard architects in town here. They really look at it as this opportunity to create it's just a free environment. So you don't have to design around a column. In 20 years, when that use of that building changes, again, you don't have to worry about, well, there's a column here and I can't move it, so I can't really have this space here. I'm a pretty simple guy, and I think about sustainability, but I really still think about it in the old adage of reduce, reuse, and recycle. And here's a great way to, one, we reduce the amount of concrete that ultimately goes into a building, but then we create a situation where it's so reusable. None of us know what that building is going to be needed for in 20 years, 50 years, 100 years. But what I can tell you is you have a wide open platform to build with. So you don't have to worry about, is that column going to be in the way later? It's like, just take everything out and you have a whole open floor plan to start with again.
So yeah, going back to kind of the mixing and stuff, is there more testing required because it's so high strength? And then what's the kind of the finish look like? Is it different than what you're typically doing with precast and the kind of the typical grades of concrete?
Yeah, so the testing is very similar. We do still test it for compressive strength. We test it for air to make sure that we didn't trap a lot of air in it. And then we also have to do flexural tests on it. So we pour a small beam and do a flexural test on it, since that is the most important attribute that UHPC brings over traditional concrete. One thing we did notice, in that list of questions you asked, is there any special equipment we have to use? Well, our typical cylinder brake machine doesn't have enough force in it to break a UHPC cylinder. So we did have to buy a new cylinder machine. And the other thing we had to buy then was a end planer. So the ends of that cylinder have to be extremely parallel and flat, because the neoprene pads that we use on traditional concrete to make sure that the force is equally divided over the whole round of the cylinder, well, they're not hard enough to actually work with UHPC. The sulfur caps aren't strong enough. So you actually have to polish them to, I'm going to say, perfectly parallel to each other. And then you go and steel onto the concrete instead of using a pad in there. So there are a few small, they're pretty easy hurdles to get over, but there are a few different things in the testing just to make it work.
Wow. I guess that makes a lot of sense. Does it, when you're crushing and breaking those cylinders, do they fail in the same manner that you'd see other cylinders? There's there are 5 different types or whatnot of failures.
Yeah, you won't get a shear, you won't get an explosion, because of all the steel fibers in it. And the structural stuff, it's got so many steel fibers in it that you aren't going to get this sloughing off of a shear or something like that. So you're just going to see it happen, and it'll just kind of rupture out a little bit. But the steel fibers ultimately are holding it together still.
Wow. So why was UHPC developed? Where did this come from?
It was developed in, I don't know if it started in Malaysia in that area, but that's definitely where it's most prominent. But ultimately it's developed to be able to do more work with the same amount of concrete or the same work with less concrete. So you can do more, and you really see it in Malaysia, in other areas like that. There's one engineer, I don't know if he's a professor or not, but I think it's Dr. Wu, but he really embraced it in that whole bridge infrastructure side of things. And, they're creating 300-foot clear span bridges over there now. It's just something we're not doing here, but that's where it really starts to set itself so much farther apart than other materials, is that you can create things that you can't otherwise. And when you're doing a post-tension 300-foot bridge, that compressive force being up close to 20,000, then it does become a really, really big part of that concrete as well.
Yeah, it seems like, bridges, doing a little research of UHPC, seems like, the resiliency of it, it's not very porous, as you mentioned, it's
Right.
sand. And
Right.
it seems like it's really beneficial from a longevity standpoint.
Yeah, again, it is such a dense product that absorption just really isn't a thing in UHPC. And what destroys concrete out in the open, it's freeze thaw, especially when we salt a road or a bridge. So using it in that bridge work where they get more freeze thaw cycles, it's just a no-brainer. It's going to hold up so much longer than a traditional concrete bridge, or steel for that matter.
So I'm guessing there's still pre-tension strands and rebar utilized in it, or what does that kind of look like?
Very little rebar on the beams. So we made some beams that were 70 feet long, and we used some rebar at the two ends. No, I'm not an engineer, so I'm not going to try to remember why we had to have a little bit of rebar at the very ends, but we had some stirrups at the very ends. But then we did have 26 pre-tension strands. I think it was 26 in the bottom of every one of them. So they're definitely still very highly pre-stressed. In fact, you can put more pre-stressing into them because of that compressive strength.
Yeah, are you having to use like higher strength tendons or higher strength rebar at all? Do you know?
Not we use the same grade 60 rebar. And then for the strands that we use, we use either 1/2 inch or a 6/10 strand. It's all 270K, so it's not necessarily stronger steel. But we did use more of the 0.6 strand than the 0.5 strand because we wanted that extra compression.
Okay. So yeah, Max and I often think of like, all the different materials and the way to design them as pieces on our tool belt. As an engineer, where do we put UHPC in our tool belt if we're, designing commercial buildings or bridges? When do we think about using that versus just typical concrete and precast?
So it's a great question because we're on such the forefront of bringing UHPC to the market. So there aren't a lot of case studies. In fact, that office building that we did downtown is the first commercial building, for surely office building, completed in the U.S. with UHPC. So I can't give you 5 great examples of use it here, but what I would say is when you're looking to create a different value, if I just talk about a building and stay away from infrastructure right now, when you're looking to create a different value, in that case, we got rid of all the interior columns. So I think it's a really unique way to look at solving some of the problems that we're so used to just accepting. So if I was in front of an engineer and architect right now, the questions I would be asking is, what compromises are we making that you would like to get rid of? If we're doing, we can also use UHPC as an architectural facade element. So again, my question would be, what is it that you would like to do that you think you can't right now due to a limitation? And how do we see if this is an opportunity to create something different for you?
So yeah, you mentioned that the structure was steel, and you came in and were able to do it out of UHPC.
Yep.
My thought comes to what are the cost implications of that? You said is similar or close, or could I guess elaborate on the cost of UHPC on projects?
Yeah. So first, UHPC, a yard of UHPC concrete is going to be 6 to 8 times more expensive than a yard of traditional concrete. So we can make a yard of gray concrete, structural concrete, for about $150 a yard in the form. UHPC is going to cost us about $1,000 a yard in the form. So the first thing that we have to do is just say, I'm not using UHPC in my traditional forms. It's just way too expensive. So when you switch to UHPC, you have to design an element that maximizes the capabilities of the UHPC concrete. So what we saw on Steel District and what we are seeing as we're designing some podiums right now is that, we can get about half of that structural concrete out of a system, out of that beam, I should say. So it's still more expensive, but what I also got rid of then is I got rid of some columns. So there's some more concrete that went away from the precast, but also now I got rid of some concrete from your footings and foundation package because you don't have to put a footer there. The other thing that we're looking at on these podiums is I think I can make them flat enough, and we'll just call them carpet ready, that you now have eliminated that 3 inches of topping that they traditionally have to come put on a fire separation. So now I also eliminated a whole bunch of concrete that would have to get poured in the field. So the challenge always is getting somebody to sit down and really pencil out the whole picture of traditional build and the whole picture of UHPC build. I believe, and I can't substantiate this with hard numbers yet, I believe that we're going to be very close. Probably first cost is still a little bit more expensive than a traditional setup, but we'll be in the ballpark. We'll be close to the same price, but we bring you a lot of different values. So if you're talking again about a retirement community and you don't have any columns in the parking space, what's that value worth? And can you then, as an owner, get that value out of your, whether it's rent or usability of that building?
Yeah, I would think too, you have less pieces if you have less columns, bigger girders or longer span girders. So just the
Yeah.
speed of construction alone saves, I'm sure, a
Right.
big chunk of cost.
Right. We're working on a change where, in order to go promote this, we need to have some case studies or some examples we can show. So we worked with eConstruct and took a fire separation that we did a couple years ago using a traditional beam column and hollow core plank as the fire separation. And there were about 430 pieces of precast to make this fire cap. We think we can do it in 42 pieces using UHPC with a flat slab poured on top of it. So it's just, we can set that in a week. And the other fire separation is going to take you 3 or 4.
Right.
So again, if we look at the whole picture, you're generating revenue in this building now 3 weeks earlier, a month earlier. That's huge. And then you don't have to pour topping on it. So that's going to take away now a couple weeks of time as well. So you could have 2 months of time savings on the overall schedule. And that's where, again, if we look at the whole picture, UHPC is going to be a viable material.
Man, that makes a lot of sense. And then, yeah, you tie that to no columns, the longevity of UHPC. I mean, from an
Right.
engineering standpoint, it sounds awesome, right?
Right.
The code drives to this like 50-ish year building. Now we're talking way longer lifespans, and like you said, there's so much more use to the building without columns. And how do we, lay things out? And I know it comes up like at least in hospitals all the time, like putting brace frames in the building and columns and
Right.
laying everything out, and they always want to change it. So,
Right.
man, that's really cool.
Right. I think that the medical environment will be a great use of UHPC in the future. I really think once we get it established and those architects and engineers who are designing those understand how to use it, I think it'll just change that environment quickly.
Yeah. So do you think there will be a point where it's being utilized enough to where just the cost of the materials will come down, that cost per cubic yard, or are we kind of set at a price just from a
I think
material
you can
standpoint?
get it. I think you can get it down some with more demand, because then the industry will ramp up and be more ready to supply some of the materials. But one of the biggest drivers itself is just we use a lot of cement powder in it. You need all the fine particles. We use a lot of cement particle or cement powder in it, and that's one of the most expensive ingredients we use in concrete. So you aren't going to get it to half that price over time, because like cement powder is not getting cheaper. We use some silica fume in it, which isn't terribly expensive, but it's not a cheap product. I think the steel fibers can come down over time, because if they become more mass produced than they are today, then I think companies will find a better way to get them, deliver them, and use them. But in general, it's not going to get half price, but I do think we can get it down a little bit from where we're at today.
Yeah, that makes a lot of sense. I was surprised too to see online how much the steel fibers cost. I'm guessing
They're
it's
expensive.
just not used enough. It seems like a simple manufacturing process, but I don't know.
Yeah, I couldn't agree more. And we're pretty fortunate. We have a person that we know in the precast industry who's extremely good at sourcing materials. So we've had him working on finding us materials more from the source and not third hand, which does help control the cost some as well. But there's a lot of fibers and they are expensive. Yes.
So I think probably the last question maybe I want to ask here is on your project, the Steel District, what was the biggest lessons learned that you could pass along to the next or the future design teams that would be using UHPC?
For the future design teams on a job like that, if we're going to convert from a traditional way of building a building to a new way, it is just imperative to get us on board early. Just have those conversations early. On the Steel District, the structural engineer of record and the architect both had to essentially just redo the building with the new design. And it's a complete waste of resources, really. So while I push for it on all precast buildings, because I think there's so much value we can drive in a building by working together early, if we're going to convert one over to a new system of building using UHPC, it's just so important to get in and work together and make that design work and not try to shoehorn it into a traditional way of thinking.
Yeah, makes a lot of sense. I guess, last question. What questions have we not asked that you think would be important for our listeners to know about either precast or the use of UHPC?
I kind of want to talk a little bit about the sustainability side. And I think there's some yin and yang on that sustainability because we use more cement powder. And cement powder has a huge black eye in its use right now. And again, I think numbers can be shown to tell any story we want it to tell. But at the end of the day, it's got a black eye and people are against it. But I think we're asking the wrong questions sometimes in how we look at sustainability. And if you look at a precast building, I'll use the Supreme Court in Colorado. It was designed as 100-year building. If you use 100 years for your life cycle analysis for all the energy that goes into that building, it comes out very differently than when they're using 20 or 30 to compare us to. And I think with UHPC, the reality is we need to be looking at it over 200 years, not 30 or 40 years. And if you take an LCA over 200 years, it will prove to be an extremely sustainable building product. So I think that somehow we've got to be looking at more of the picture and make sure we're using the right comparisons and the right adders and multipliers and dividers to really get the picture of, these buildings are going to be here for much longer than what we're used to in the United States. I'm thinking there's buildings in Europe that are thousands of years old, right? Do it like LCA in those ones, and tell me they're not super sustainable. And I think we need to one, be designing buildings that can have that type of longevity. But then when using UHPC, expect it and then use our numbers accordingly.
Yeah, it makes a lot of sense, and I think the resiliency to that too, right? Or we talk about often that our buildings aren't resilient enough. Something I know that the West Coast at least looks at a lot with all their seismic challenges.
Right.
But yeah, seems like this would make our road infrastructure more resilient, our building infrastructure more resilient. It really seems like the right choice for much of what we do.
Yeah, I'm very biased, but I do agree with that.
I'm like sitting here trying to just think how I can poke a hole in that, and nope.
Nice.
It makes a lot of sense. It's so logical. So, well, awesome. Well, thanks for joining us today. I'm sure I learned a lot. I'm sure our listeners will too. We'll put your guys' information down in our show notes, so if they have any questions, they could reach out to you. But thank you so much.
Well, thanks for having me on, guys. If you have any follow-up questions, reach out.